Hello dear friends, this is Himmet again. I already gave you 5 lectures at last 5 weeks. Now we continue our lecture by using the video method from now on. This week we deal with the topic of improper integrals. Details can be followed from PDF form, which is in Erudum portal of our university. From now on, we follow this video method every week. Furthermore, after the lecture, I also give you homework about the topic. Thank you. Let's begin our lecture. Our lecture name is Lecture 6A, Improper Integrals. Now, actually we have two kind of improper integrals. First one is infinite integrals. We call this type 1. Now, let integral from a to b f of x dx be given integral. Now I would like to define what is infinite integrals. If a and b are minus infinity or positive infinity, then we call this type of improper integral as infinite integrals. Okay? Now, actually we are saying that upper limit or lower limit is infinitive, then we call such an integral infinite intervals. Now, I would like to correct here intervals. Intervals. Okay. Now we have 3 type of infinite intervals. First one is from a to infinity integral f of x dx. This is equal to limit b approach to infinity integral a from a to b f of x dx. Okay, now we have for this term 2 possibilities. First one, maybe this limit is exist. Exist means that if we have a real numbers, then we call this given integral as convergent. Convergent, okay? If this limit non-exists, at that time we call this given integral divergent. Okay, now second type is from minus infinity to b f of x dx. Okay, we can write this integral as limit a tends to minus infinity integral a from a to b f of x dx. Now we have again here two possibilities. This limit maybe exists or non-exists. If this limit exists, we call this given integral convergent. If this limit non-exists, then we call this given integral divergent. Okay, now the last type is integral from minus infinity to infinity f of x dx. Okay, now this is our interval from minus infinity to infinity. Let's take a point here, point C. Okay, then we can write this integral as minus infinity to C plus from C to infinity. As you can see that this is our second type. This one is first type, infinite intervals. Okay, now if this and this convergent, then we call this given integral is convergent. If this one or this one is not convergent, which is this one or this one non-exists, at the time we call this given integral divergent. Okay, now I would like to give some example to explain now this theoretical explanation. Okay, now examples. All right. Our first example is one integral from 2 to infinity 1 over x cube dx. Now, as you can see that we have a infinite integrals. Our upper limit is infinite. Then we can write limit b goes to infinity integral from 2 to b 1 over x cube dx. We know how to calculate such an integral, then we can write limit b tends to infinity. I think we can write this part x minus 3, and so if we add 1 and divide the obtained number, minus 2 over minus 2 from 2b. Okay, limit b approach to infinity. I think we can write here, we can write this bracket like this: 1 over minus 2 x square 2 from 2 to b. Okay, let's write last time limit b approach to infinity. First, let's put upper limit in this term: 1 over minus 2 b square minus, we have another minus, plus. Now 2 times, if you put 2 in as x square, 2 square is 4. Okay, now let's look at what happened. As b tends to infinity, let's use red color. This goes to, of course, 0, and so our result is 1 over 8. Our result is 1 over 8, which means that our given integral is convergent. Okay, our given integral is convergent. Right. Now, I would like to take another piece of paper. Let's write here number 2. Okay, number 2. The second example is example 2, integral from 1 to infinity x square dx. We can write that limit b as b approach to infinity integral from 1 to b x square dx. Now we know how to calculate such an integral because this x square is a polynomial, and then we can write that limit as b tends to infinity x cube over 3 from 1 to b. Okay, let's write last time limit b as b tends to infinity. Let's put upper limit b cube over 3 minus, if we put 1 as in x cube, 1 over 3. Okay, as you can see that as b tends to infinity, b cube tends to infinity faster than b, and so this is tends to infinity, and so our result is infinity. So our given integral is divergent. Right, our given integral is divergent. Example 3, integral from minus infinity to infinity 1 over 1 plus x square dx. Let's consider this example. Okay, right. Now our interval is from minus infinity to infinity. We need a point between minus infinity to infinity. Let's put here 0. I am taking 0 because the integral of this integrand, we know that arc tangent x, and so we need known value, first one 0 or 60 or 45 or 30 degrees. Now I am taking 0 degree. Our integral is minus infinity to 0 plus 0 to infinity. Okay, let's call this one I1. The second part, let's call second part I2. What is I1? I1 is integral minus infinity to 0, 1 over 1 plus x squared dx. Okay, limit a tends to minus infinity, a from a to 0, 1 over 1 plus x squared dx. We know this integrand, how to behave such an integrand from we have 13 formula, and so by using that 13 formula we can write that limit as x tends to minus infinity. Our integral is arctangent x from a to 0. Okay, now we can write, I think, limit a tends to minus infinity, arc tangent 0 minus arc tangent a. Okay, now let's look at, we know that arc tangent 0 is 0 as x tends to minus infinity. This is arc tangent minus infinity. Arc tangent minus infinity is minus pi over 2. We have another minus, and so our result pi over 2. Okay, now this part is the first part. Our first part is convergent. We can write convergent. Now let's look at the second part. Okay, I2, integral from 0 to infinity 1 over 1 plus x square dx. Okay. Limit. As b tends to infinity, I think we can write from 0 to b 1 over 1 plus x square dx. We actually, as you can see, that we calculate this integral here, which is first part, and I think we can write limit b tends to arc tangent x from 0 to b. I think we can write limit as b tends to infinity arc tangent b minus arc tangent 0. We know that arc tangent 0 is 0 as b tends to infinity. Arc tangent infinity is pi over 2. Our result is pi over 2. Again, the second part our integral is convergent. Now the result is we can write our integral I1 plus I2. We know that I1 is pi over 2. Pi over 2. I2 is again pi over 2. And so our result is pi. And so we can say that, we have to say that our given integral is convergent and its value is pi. Our integral is convergent. Okay, our integral is convergent. That's all. Thank you. See you next lecture.